Okay guys, this video is going to be over 4-6, which is over the quadratic formula and the discriminant. What I would like to do is, again, these particular problems are a review over 4-5, so you are more than welcome to try them out. Remember to go back over the square root property. You can look it up in your textbook, work this problem out. And then we did introduce and start completing the square. I'm putting a star by it because I want you to just use the textbook. And again, some groups we did not get to go over completing the square. I think block 5 is the one that we began to already jump into it. Block 3 you have not done it. So I'm just going to leave this open for now. So that when I come back to class, we'll start from here. But I want to go ahead and introduce 4-6 to you. At this point, we're pretty much done with chapter 4. So we've covered everything from 4.2 all the way to, I'm showing now 4.6. I will post a review sometime later tonight or tomorrow, so that there'll be something that you can start to look at. But your main thing is to do the homework assignments that are in the lap, and then the questions that you can check in the back, do that. And then when I come in and I see you guys, you can ask questions from there if there were any problems that were giving you any concerns. And then of course we will work on more review problems to get ready for the test and go from there. Okay, so again, this video is about the quadratic formula and the discriminant. So I'm going to leave this slide open, and then I will discuss these when I come back to class. Alright, so let's go to, close this real quick, the next slide. Alright, so in this slide, this is the formula for the quadratic formula. It's really, really important that as you take the SAT, the ACT, any standardized test, and just any parts of algebra, you want to know the quadratic formula, because one of the major things in algebra is knowing how to solve quadratics, okay? And now, there was one group where we reviewed over what are all the ways to solve a quadratic, and in this PowerPoint, you'll see that there's a summative slide that shows, you know, all the ways that you do it. So the easiest way, of course, is to factor. That's the quickest way to get to your roots and find your x-intercepts. The next quickest way is completing the square, which we really need to make sure we practice more of that together as a group. And then the next and last way is to do the quadratic formula. It takes a little bit longer because, as you can see, I'm going to circle this real quick. It's a pretty extensive formula, and there's quite a few keeping the signs straight, and where does A go and C go and B go. One of the biggest things that I always see is people forget to keep that negative on the negative B. So again, please commit this formula to memory. It's really important. And so the first thing you always want to do is you want to get your quadratic equation to be in standard form. So make sure you set it equal to 0, and then again you can identify what your A, B, and your C term is, and then you just plug them respectively into the formula very carefully and watch your arithmetic. Okay? Alright, so I'm going to move to the next slide. Again, please put a star by this formula, study it, make flashcards, do whatever you think you need to do. Alright, so now let's just talk about a couple of things here. So, it's a little small, I'm zooming in. So it says, consider that you have the standard form, ax squared plus bx plus c is equal to 0. A, b, and c are rational numbers. Okay, a cannot equal 0. And here's the breakdown, okay? So this slide is about the discriminant. So here's another formula. So if you can remember, I'm going to just put it on the side, b squared minus 4ac. Okay, this is the discriminant. Nice word with a lot of I's and N's. Okay. Alright, so when you sit back and you look at this formula, what this is telling you is, if you can sit back and remember the discriminant formula, you can go ahead and tell before you start working a problem out how many real, how many irrational, and how many solutions your quadratic has. Okay, so in this case, look at the first row here. If b squared minus 4ac is greater than 0, and the value, when you plug in your b, you square it, you subtract away 4ac, if it's a perfect square, it will have 2 real rational zeros. Okay, 2 real rational roots. And so as you can see, you'll have basically 2 x-intercepts. Okay, keep that straight. Now here's the next condition. Same thing. If you do b squared minus 4ac greater than 0, but if the value when you calculate it is not a perfect square, then you will get 2 real, but you'll have irrational roots. And we'll see one of those hopefully either in the homework or as we do some of these problems. So let's keep going. If the determinant, sorry, I said determinant. If the discriminant is equal to 0, then there will only be one real rational root, so you only have one x-intercept. And if the discriminant is less than 0, so if you get a negative number, once you plug in your b value, square it, subtract away 4ac, you get two complex roots. And remember, complex roots are like that a minus bi or a plus bi, right? That there's a real part and then there's an imaginary part, which makes it a complex number. All right, so as you can see, this I'm going to put right here, imaginary number. Let's put a plural numbers, right? So again, remember that quadratics have two solutions. There can be two complex roots. There can be one real, because in this case, again, you only have one x-intercept. You can have two real, but again, if there's a perfect square, rational roots will happen. If it's not a perfect square, you'll have two real irrational roots. All right, so let's get into an example. All right, so on this one it says, describe the roots. So describe the solutions. Find the value of the discriminant. So I'm going to go ahead and, as soon as I read that, I'm going to write my formula right here. So I have b squared minus 4ac. That's the formula for the discriminant. And they give us an equation. And then describe the number and the type of roots for the equation. So I'm going to write it again here. Move pretty quick. So right here I'm going to start listing what my values are. So a is equal to 1, b is equal to 3, c is equal to 5. Very carefully I'm going to just start plugging it in. So I have b, which is 3 squared minus 4, a is 1, and c is 5. Now I'm going to calculate that. So I got 9, put my minus, and I like to do my multiplication here. So this is a 20. So when I do this math, this is going to be negative 11, right? So I'm going to come back here and I'm going to say, I'll come over to this side here. I have 9 minus 20, which is equal to negative 11. All right, then I go back at this slide and I say, okay, if my discriminant, well, I'm not greater than 0, it's this last one right here. Less than 0, because I got a negative, I'm going to get two complex roots. So I'll go back and I'll say discriminant, which I think they actually, check in the textbook for me, I think they just use a capital D. So let me just, instead of writing the word out, so since D is less than 0, D equals negative 11, we get two complex roots. Okay, I also would tell my teacher, you know, I just put the word imaginary somewhere. Okay, and so we have now described the type of roots. Right, let me kind of zoom out. All right, so that takes care of A. Don't be as messy as me. All right, so let's do the next one. Find the value of the discriminant. So I write the formula again, b squared minus 4ac. The more you write it, the more you'll commit it to memory. And so as you can see here, I'm going to write the problem. So a is equal to 1, b is equal to negative 11, c is equal to 10. Okay, and so I'm going to just carefully plug it into the formula. So I got negative 11 squared minus 4a, oops, put an extra parentheses, put a 10 there, and carefully do our math. So we got 121 minus, and then I do 4 times 1 times 10 is 40. I'm going to just subtract away 40 from this. 1, 0, 12, 81. Okay, and so because this is greater than 0, I go back to my slide and I say, hey, it's the first one, or the second one possibly. If b squared minus 4ac is greater than 0, but if it's a perfect square, it means I have two real rational roots, which means I can just have nice clean numbers like negative 10 or 2 or 15, or even a fraction is okay, right? So we go back here and I'm going to zoom out. Okay, zoom in, sorry. And so because this is greater than 0, and then because 81, I'm just put a note right here, 81 is a perfect square, I'm going to get two real rational roots. So that tells me ahead of time that I'm going to get two x-intercepts, and they're going to be nice clean numbers. They're not going to be imaginary. Alright, so I hope that makes sense, and I'm also going to put that capital D back here. Alright, so that's the discriminant. Just going to underline that. Please commit that formula to memory. All right, so let's keep going. Now they want us to solve this problem using the quadratic formula. So here we go with this one. Now again, you want to first put it in standard form. Okay, so I'm going to rewrite this as x squared, leave the 13x, and I'm going to move the 30 over to the left side so it becomes negative. Right? Now I'm going to list that my a is 1, my b is 13, the c is negative 30. I'm also going to, because I'm going to underline this, write my formula, negative b plus minus square root b squared minus 4ac. All that is under the square root, okay? This is all being divided by 2a, okay? I also, real quick, I'm going to put an x there. Okay, so let me go back. Let's look at this formula, make sure we got it right. Negative b plus minus square root b squared minus 4ac, all divided by 2a. I have a lot of people, when they do this, is they forget that that 2a gets divided by everything. I have my formula correct, and I'm going to carefully plug in and watch my signs. Okay, very important. Now remember, whenever you have a quadratic, I can't stress it enough, you're thinking that you're going to get two solutions. And so again, that's why that plus minus is there. Okay, so here we go. Put the x. So I got negative, b is 13, plus minus, put my square root, parentheses, I'm going to put 13 squared minus 4a. My c is negative 30. Watch your signs. I'm going to extend that radical or that square root so everything is under there. This is all being divided by 2 times 1, which is just, let's just put a 2. Alright, so watch my math, okay? So I got negative 13, put my plus minus. Now what I like to do, draw my square root, is I first squared the b, 169. I put my subtraction symbol. This is how I do it. You do what you like. Be careful. I squiggle under this and I say, let me do my multiplication and leave that subtraction symbol. So I know negative 30 times 1 is negative 30. Negative 30 times 4 is negative 120. So you see now I can see that that's going to change to a positive. And I'll put my plus plus, right? And then from there, I'm going to put my 2. So here's the final step. So I still have that negative 13 plus minus, and I'm just going to add those two together. So 169, excuse me, plus 120. Yeah, I'm so sorry, 289. This is 289. It is still under the square root, and I know the square root of 289 is 17, I believe. Divided by 2. Final step, negative 13 plus minus 17, because it's perfect squared, divided by 2. So here are your two solutions. I'm going to try to squeeze this in the best I can. Okay? So one solution is negative 13 plus 17 over 2. The other one is negative 13 minus 17 over 2. So I'm going to just, I know I wrote really big, guys, I'm sorry. So I'm going to put my answers right over here on the side and box it. So x is equal to, so if I have negative 13 plus 17, that's 4. 4 divided by 2 is 2. And then my other answer, this is going to be negative 30. Divided by 2 is negative 15. So these are my two real rational roots or zeros. Okay, so I got 2 x-intercepts. And then the cool thing is, let me just see if I can go on the side here. Will it let me write right here? Yep, it will. Good. So one thing I wanted to do real quick is, let's just say before I even started using the quadratic formula, I want to see how many roots I would have gotten before I even did the formula, right? So let's look at that discriminant. Remember the discriminant, the cool thing is, you see how it's right here under the radical? It's already in the quadratic formula. So I'm going to do b squared minus 4ac. My b was 13 squared, 4a. My c was negative 30. Alright, so I got 169 minus 120, because that's what I got in my math. See that there? And that right there is that 289, which is greater than 0, which again, you go back to that slide. 289, that first one, is a perfect square. So because that's a perfect square, I would have known it was 2 real rational zeros, or roots. Alright? Everybody good on that one. So let's see what's next, because there's only a few more slides. They want us to do it one more time. So I'm going to do this once more, really quick. X squared, subtracting the 6x over, leaving the 13 positive, setting this equal to 0. Write your formula. This. Okay. 2a. Alright, carefully plug everything in. So, now watch this one. You have negative already in the formula. But as you can see, and let me also not skip a step, my a was 1, my b was negative 6, my c was 13. Okay, so watch that b is already a negative, so you got minus minus right here. That's, like I said, people miss that on the outside. So I'm going to make that a plus. Now I got my plus minus, and I'm going to do 36 minus 4. A is 1, c, I'm squeezing that in, that's 13, all under the radical. And this is all being divided by, again, a 2. Alright, so here's the math. X is equal to 6 plus minus, and 36 minus, now again, I like to multiply this out. 13 times 4, 52. I'm doing my Spanish work. Guys, I'm sorry. I'm kind of tired. 52 minus 52, right there, boom, all divided by 2. Then I'm going to go ahead real quick, and I know this is going to be a negative number under the square root, which we know about negative square roots, right? But let's just subtract 36 away for a moment here. So I'm going to get 16, but I know it's going to be a negative 16. So this is negative 16. If I take the square root of negative 16, I get 4i. So I got 6 plus minus 4i, all divided by 2. And remember that because all three of those numbers are even, you have to reduce them all by 2. Okay? So it's really important that you can say, oh, 2 divides into 6. That gives me a 3 if you want to separate it. And then 4 divides into 2. So here's the answer. And as you can see, this is a complex number. So your two solutions are x is equal to 3 plus 2i. X is equal to 3 minus 2i. This is the answer. And complex numbers, of course, are imaginary. Now, one more time, just for me to show you the discriminant real quick. So if I would have done that b squared minus 4ac before I even started using the formula, I would have already saw that I was going to get 2 complex roots. So I'm going to just go ahead, and again, the math is already right here, you guys. Okay? So again, that negative 16, not the square root part though, but that negative 16 is less than 0. And if you go back to this slide here, the last one down here, it says that if your determinant, I keep saying determinant, your discriminant, if it is less than 0, then you get 2 complex roots, and they're imaginary. So you go here, okay, and like I said before, let me zoom back in, sorry about that. So I got negative 16, which is less than 0. And so again, this is, I got 2 imaginary numbers. Okay, so I hope that makes sense. It's really, really easy. Make sure you do the textbook assignment. Now let me show you one more slide. Okay, this is summarizing everything that we've done in chapter 4 as far as solving quadratics. All right, so first you have to know how to graph them. We will talk about that more. I'm going to show you a lot of different strategies and tips when we do the review questions. So we're really, really ready for this one. I want everyone to get an A on this chapter test because I think it's straightforward, but I'm not going to lie to you. Listen carefully, okay, to me, that quadratics come up so much in math. Like we're going to do it. It's going to be easy. It's fresh on our minds. But when we move away from it, you have to keep this stuff straight because they tend to bring it back up in algebra a lot off and on. So I really want to make sure that you get down really, really good how to solve quadratics and always graphing them and everything. Okay, so here are the ways to work with quadratics again. You can graph them. And you've heard me say this before. If you have a brain fart and you don't remember, make a t-table, which means you just choose some negative x values, 0, some positive x values, carefully plug everything in, and then plot your points. That simple, right? You also can do the axis of symmetry, which, remember that's when you have x is equal to negative b over 2a. You get that x value, you plug it into the original equation or function, you get a y, and then before you know it, now you see, you have the vertex, which that's also another thing they call H comma K. You have your vertex, and then from there you can choose some points to the left of the vertex, to the right of the vertex with the t-table, and you can graph that way as well. Okay, second way, I'm going to use numbers now. Factoring. So first way is graph. They may ask you to do that, of course. Factoring. This is, everybody does it their own way, but you factor, and this will give you your two zeros, or your x-intercepts. And then from there you can still go back to the axis of symmetry and have the vertex, and now you have 3 points, and you can also graph it after you factored. The next method is, they said, the square root property. You have to be able to get it to look like this in this form, where there's some kind of, you factored, and then you have a square, you square root both sides, and then you get your two solutions and move your constant over. Completing the square is one that we're going to spend some more time on. I want to make sure you're also good on graphing. Please get good with factoring. And then the one I just introduced today was the quadratic formula, which is number 5. Okay. All right. So that ends this video. It's just 20 minutes, and I hope it makes sense. Make sure you do the problems in the lap. Let me see real quick if I can. Don't save. Let me see real quick if I can open up the lap, just so I can just summarize real quick at the end of this video what all we've done. Oh, it's not letting me do anything.